So question 10, it says a coach travels from Dronston to Lusco and you've got a travel graph shown, and it says, first of all, work out the average speed of the coach in kilometres per hour. And this is for the first 10 minutes of the journey. Well, shown on here, if this is the first 10 minutes here, then you can see that it's actually gone 9 kilometres in 10 minutes. So we've got 9 kilometres in 10 minutes. So you've got to think to yourself, how do you get this into hours? Well, if you multiply this by 6 here, and you do the same to this side, then you'll get 60 minutes, which is the hour you wanted, and then 9 times 6, either in your head or in a calculator, will be 54 kilometres in 60 minutes, which is 54 kilometres an hour. Then it says the coach stops in Lusco for 15 minutes. The coach then returns to Dronston at a constant speed of 42 kilometres an hour. Well, we can definitely sort out this part first. So it stops for 15 minutes, therefore it's not travelling any distance at all, so it's just standing still for 15 minutes, and we can show 5, 10, there we go, 15 minutes there. And then the coach has to return at a constant speed of 42 kilometres in 1 hour. Well, the first thing to notice here is, if you read up to here, what distance do you think that is? Well, you've got 3, 6, 9, 12, 15, 18, so it's got 21 kilometres to go. So if there's 21 kilometres to go, and you want to work out how to draw this on the diagram, then you've got to really think carefully, because we've got to go at 42 kilometres an hour. So a nice way of doing this is to say, if we've got to go 42 kilometres in 1 hour or 60 minutes, then surely what have we done here to get from 42 to 21? We've halved, haven't we? So if we divided by 2 to get from 42 to 21, then we're going to have to do the same here, which is divide the 60 by 2 to get 30 minutes. So we've just got to go 21 kilometres in 30 minutes, and that will be the same as 42 kilometres an hour. So we can show that quite simply by just reading along here first. So if we go 5, 10, 15, 20, 25, 30, we've got to end up here. So we're no distance from Dronston, i.e. we're at Dronston. So I'll try and draw the straight line. And there we have it. So that's our travel graph complete now. Question 11, we've got to solve 3x squared equals 147. And keep in mind that you do have a calculator. So the first thing I would do is I would divide both sides by 3 first of all. And that would give me x squared equals, well, if you can't do 3's into 147 in your head, that's fine. You can do it by long division. So we got 4 3s are 12 with 2, so we get 49, and you can use your calculator, don't worry about that too much. So x squared equals 49, and then what we can do to get x is to do the inverse operation of squaring, which is square rooting. So we would square root both sides, and that would give us x equals plus or minus 7. Now don't forget, if you have a square root of a number, say 100, then its square roots will be 10 and negative 10. Why? Because 10 times 10 is 100, but also negative 10 times negative 10 is 100. So when you've got the square root of a number, it always has its plus and minus counterpart. So here we're going to say the answer is not just plus 7, but plus or minus 7. The next question says, or the next part of the question says, work out the value of 2 to the negative 3. Well, in earlier videos I did a bit of a longer explanation here, so I'll cut this down a little bit. If we had 2 to the 3, that would be 2 times 2 times 2, which would be 8. 2 squared would be 2 times 2, which is 4. Notice I'm halving each time here. 2 to the 1 would be 2. Then we'd have 2 to the 0. Well, we've got 8 halved is 4, halved is 2. If we halve that, we'd get 1. And then 2 to the minus 1, that would be half of that. 2 to the minus 2 would be a quarter. So the answer to 2 to the minus 3 is going to be 1/8. And some students see a shortcut for this. They say that this negative part inverts the question. So we'd have 1 over 2 cubed, and you know that 2 cubed is 8, so that's the same as 1/8. So indices can be quite difficult, but on other videos that I've done, I've gone into a bit more detail on it. So that will be the answer for part B. We now want to simplify this, so we've got 3x squared all cubed, and that's going to be equivalent to 3x squared times itself again. Okay, so it's cubed, and if I put brackets around here, which are not necessary, but so you can just see how many times I've written 3x squared, and it's multiplied by itself 3 times in a row, then if you do the numbers first, you've got 3 times 3 is 9, times 3 is 27, and then x squared times x squared times x squared, well, you can add the powers here, you know that, so you have 2, 4, you'll have 6, so it'll be x to the 6. So the answer would be 27 x to the power 6. For this last part, you have a formula here, say w equals 4p minus 16, and you must make p the subject of this formula. Well, if you look closely at some of the other videos that I've done a couple on rearranging equations, and I strongly suggest that you look at those. The videos are very long, but you can just look at a couple of questions at a time, and I go into some from very basics right up to past A star and the beginning of A level. So definitely look at some of those. But for this question here, we want to make p the subject of the formula, so we want to have p equals, and then whatever's left will be the answer. So first thing to do is we could add 16 to both sides, and then we'd get w plus 16 equals 4p, and then we just want p because we want to make p the subject of the formula, not 4p, so we want to divide both sides here by 4, and that would give us w plus 16 all over 4 equals p. So you could leave your answer as that, or you could just reverse both sides, as in like switch the sides over. So it's like a pair of scales. If I'm facing the scales, I see it one way, and the other person on the other side will see it the other way round. It doesn't really matter, but you can just write your answer, p equals w plus 16 all over 4. Some students might write this as w over 4 plus 4. Why? Because if you divide w by 4 and then the 16 by 4, then this 16 divided by 4 becomes this 4 here. So there's many different outcomes, but I think the way I've done this question and the way I would do it, this would be my outcome. Although this would be okay for p, and this would probably be okay as well. Okay? Well, this question's not quite easy to do with the equipment I have, but I'll give it a try. It says, describe fully the single transformation that maps triangle A onto triangle B. So I think the first thing I would try and look at is to join up corresponding vertices. Now all I mean is just try and join up corresponding points here. So let's have a look. So there's one line going through here. So through that point here would correspond to that point here. Now I'm going to draw one through the point where the corner where there's a right angle. So let's try that one. So without messing this up, so let's do that one like so. And then already I can begin to see there's something going on here, but we'll do one more. And then let's have a look what happens when we've done this one. So let's join these up. Okay, hopefully you can see that the point 2, 1 is a point of interest. Okay, so I'll just jot that down here. So 2, 1 seems to be a point on here, okay, where all of those rays, when I say rays, I'm spelling it R-A-Y-S, intersect. Okay, so that's the first point to think about. So I want you to have a look at what I've set up here. So I've drawn a little red triangle around A there, and then I'm just rotating it around that centre 2, 1, and look, B. So we'll do it one more time. There's A, where I started, and there's B, where I finished. So that's the first thing to notice. It's a rotation, and we just want to work out now how much, in terms of degrees, A, the triangle A, has been rotated to get to triangle B. Also notice that it doesn't really matter which way round I go. So it could be clockwise, as shown here, or it could be anti-clockwise. Okay, so let's work out how many degrees it would actually be. And if you look carefully here, I've drawn the initial triangle with the north line. So there it is, north line pointing straight up. And then when it's rotated, this time counterclockwise, I hope you can see the north line is pointing straight down. So to go from a straight up situation to a straight down situation would be a rotation of 180 degrees. And just to explain that, in case you didn't get it that time, if I had my north line here, and then I ended up with it being in this situation here, then I would have gone through 180 degrees, whether I'd gone clockwise or anti-clockwise. Okay, so that's my best explanation I can do for question 12 anyway. Quite tricky, I have to say.